Hello everyone and welcome to another video of this, we can call it the C++ series, where we are sort of doing very advanced C++ stuff. So in the last video that's titled statement expressions or dealing with statement expressions in C++, we have sort of run into a very strange kind of problem. It's you kind of call it really strange, but it was strange to me. I thought that the function arguments would be evaluated from left to right, but it turns out as I've been coding C++ for 7 years now, and I didn't notice that because I sort of didn't read that much about the evaluation order or other than the some of the operators and stuff like that. But I was mostly looking at this table here, and I didn't sort of dive into how are the function arguments actually evaluated. They're not actually evaluated from left to right because compilers are going to try to generate more efficient code, and for that reason the order is not only left to right or right to left, but it's rather unspecified. And this was a great sort of surprise to me because I didn't actually think about this, and why didn't I? But anyway, we as people all miss out on some things sometimes. But yeah, in the previous video I sort of was looking how to implement a short circuit macro in C++, and that focuses on short circuit evaluation. That's similar to languages like Python or JavaScript, where we return, it's like a jump where we return the left or the right based on our operator, logical operator, be it or and. Anyway, without further ado, let's dive into the order of evaluation of function arguments problem. So a bit of a mouthful there, but it is what it is. So our problem is that, let me just define two functions. First would be the foo function. So all pretty standard stuff. I mean, while we can pretty much read the assembly, let's make sure we output something. So if you are not that familiar with assembly, you see the output of this. But usually when you code C++ at this level, it is a given, it is a done deal that a lot of people will just know how to read assembly, which is more than enough in this case. So I call a function makeS. We can see that we first call the zoo and the foo. This is because the compiler has decided that, okay, we are better off first calling zoo and then the foo before we make the actual call to the function. So I would return from the zoo, so call, push on the stack, pop, and return, and then I move on to the foo. So in programming languages, or rather scripting languages, JavaScript and Python, this is not the case. Function arguments are evaluated from left to right at all times. So as you may have seen in this note, and I've searched online plenty about this, there is no particular way to force the compiler to evaluate your functional arguments from left to right. And this might be a problem depending on your C++ implementations. For example, if you're trying to, I don't know, say have a plus function that would implement some sort of interface, let's say value v that's left and v right, and then you would need to return the addition of those two with some logic here. So then where you would need to evaluate from left to right, that wouldn't be the case anymore because C++ just tricked you, or rather the compiler just tricked you. I wonder if we switch to Clang, what are we actually gonna see here? Oh, which version should we use? Let's use experimental. Is there a standard? Yeah, let's go with this one. So actually, in the Clang compiler, now we can see the foo and the zoo being evaluated from left to right. So if we reveal the assembly code, we can see that the first call is made to foo and then the zoo, foo and then the zoo. I wonder what happens if we add additional optimization levels, such as O1 or O2. It's pretty much consistent. It is pretty much consistent. However, what if I'm just using GCC? You know, how do I get around this? And I'm probably not very sure that the Clang would always evaluate from left to right. Let's see. C++ evaluation in Clang. I actually did not research this part, but it is, we just got lucky. It is too unspecified by Clang. We just got lucky. So yeah, there are many approaches to avoid this. You can use initializer list, where you call your functions like this. I don't know, macS, and then you have the foo, and then you have the zoo. However, this just poses a really interesting set of issues, because now if you're defining a function that has an initializer list, you will have to access your elements in, or actually from the initializer list. So I'm just mostly gonna write pseudo code here, so it will definitely not compile. So let's say I have initializer list of s, and then those are my arguments, right? And then I would have s, which would be my first argument, let's say left, or s1 argument. This is not the way you access stuff from the initializer list. It's something like this. So the problem with this is you're making a copy of your object here, and you would probably need to enforce a move or something like that, and we can talk about these problems all night. It is okay to use it in for some use cases, but generally speaking, it's just not the same as a function. So I guess the closest solution that I've gotten to, we just move to GCC, is to wrap this in a macro where we have a statement expression, and then after which we call a function. So let's get to it, right? I've made some tests here where we are doing something like this. So what we want to make sure is that we first evaluate everything in order as specified from left to right once we call the function. So unfortunately, you will have to write a specific macro for each of your functions because they are actually serving as wrappers to your functions. So when you're actually referring to a macro and you're using your macro, you are as a matter of fact calling the function. It's just that you're trying to evaluate arguments from left to right. So I'm just gonna call this make s, and I'll add an underscore, and I'll say a, and but in this case we'll have I and II. So let's start writing the statement expression. So just typical stuff. Here what I would need to do is that I would have a constant expression, a constant reference to my first argument, which is going to be I. And the reason we need to do this is if you do something like this, then you're enforcing a copy, and that's really bad. If the programmer is passing a reference, that's really, really bad. But it's gonna work if they pass an R value, but it's not gonna work as expected if they pass the reference or the const reference value. But there are going to be problems with this macro, which I'm going to point out in a minute. Let's just finish this up. And then we make the call to the function. Now another set of issues that we have with this is fine because we are calling primitives. If you have C++ standard containers, you would need to use a const ref, move ref, something like that, along those lines, because you don't want to make unnecessary copies resulting in just unperformant code and whatnot. So now once we have our macro, let's put it to use, shall we? And we are safe with calling the function like this at the end of the statement expression, as it is essentially considered to be an X value, so it will not make an unnecessary copy that the GCC documentation breaks down here. Let's put this into use and let's check out the assembly and the output. So foo and zoo, right? So now we are 100% sure that we're calling the foo and that we're calling the zoo. Now let's wrap this up let's actually reference this in a variable and call, I don't know, print, just to make sure that this destructor is being called correctly, because statement expressions can be really weird, as we have covered in C++ dealing with statement expressions video on this channel. And if some of you may be wondering, why do we have two constructors in here, two destructors in here, and we call only one? Well, that's because C++, you know, has like try and catch, and once you see calls like this, unwind, resume, that means that it's like a try and catch, and then once you catch something, you'll have to call the destructor in that catch, which is something that compiler takes care of, but let's not get into that. The important thing is that there is a direct jump to the label here, and this code is not really it's just unreachable. So yeah. So once we look at the zoo, that is all great. So we have achieved what we wanted to achieve. There are a lot of side effects to this macro, and you really got to be careful with coding your macros, or wrapping your functions into macros like this, because of the constant references, move references, and stuff like that. I mean, even your function can return a reference essentially, but if it's not a local variable, from the function body, and then that's when stuff really gets interesting, and this kind of thing wouldn't work. But I just wanted to stay minimal on this video and just give a tip of how you can make sure to evaluate your function arguments in order, or in other words, from left to right, if you so desire. Alright, that would be it for today's video, and thanks so much for watching, and see you next time. Take care.